In the last few videos, we learned all the fundamental building blocks to implement simple linear regression. Here, we'll focus on putting all the building blocks together. In particular, we'll introduce a general method to implement simple linear regression from start to finish. With that being said, let's get started. Before we start any machine learning problem, we need to collect data. And in the case of simple linear regression, we want to collect various paired sets of data. And this is an example of the paired sets of data we aim to collect. Here we collected data on the average temperature, which is the independent variable, and the number of rainy days, which is the dependent variable. And we did that for every month. And as a general note, the more data we collect, the better our model is. But of course, this is just a general thing, and after a certain point, this stops becoming true. But for the most part, more data, the better. Next, we choose a cost function. And in simple linear regression, there are two choices for our cost functions. That is the mean squared error, or MSE, or the mean absolute error, or MAE cost function. And starting out, I will always recommend using the mean squared error cost function as opposed to the mean absolute error cost function, since it's the easiest to perform gradient descent with. Our third step in implementing simple linear regression is after choosing the cost function, is finding the optimal parameters of the model. So in this case, we aim to find the optimal parameters of theta 0 and theta 1. And we do this by minimizing the cost function. And this minimization is conducted via an optimization algorithm. The most well-known optimization algorithm is gradient descent. And after implementing this optimization algorithm, we now know the optimal values of theta 0 and theta 1. And after we have the values of theta 0 and theta 1, we can now use the regression model to predict future values. And that's it for this lecture. And at this point, you may be wondering how useful simple linear regression really is. After all, most phenomena in the real world don't just have one variable influencing it. And you would be right, simple linear regression isn't all that useful. However, multiple linear regression is a method to combat this, to have more than one variable's inputs. Luckily, however, most of the ideas from simple linear regression translate directly to multiple linear regression. With that being said, I hope to see you in the next lecture where we'll discuss multiple linear regression. See you then.